Yeah, thank you very much for the introduction. Today I want to present our latest joint research with the University of Singapore, National University of Singapore, Gen3DCity, Constraint-aware generation and densification of 3D city models. To give you a brief background about what we're doing, so today, this summer, we presented our first step in this research, where we automatically generated figure ground maps, zu Deutsch Schwarzpläne. So given we have a street network that maybe an urban planner lays out, we are able to generate 2D building footprints for different build densities. So for example, for a high build density, maybe for a city, or a mid-build density for a more rural area. And the question that arises is when we think about the need for housing, we have in cities, at least here in Germany, mostly only the possibility to densify, so nachverdichten oder Baulücken zu schließen, as we can see here on the left and right side. And to give you a more prominent example, maybe here just in front of our building, we have a building gap, and now we have to imagine how a model could look like, how a first draft could look like here in this area, and that's what we've worked on. So given that we have OpenStreetMap data and CityGML data, we trained a stable diffusion model that is capable of generating for a certain spatial extent and a prompt, an output, in this case a 3D model, that you would also be able to print on a 3D printer and put on your table. And basically our model, in conclusion, is able to deliver 3D models for the densification and fulfillment of building gaps, adherent to the street network, to the level of height that a user desires, and with respect to the build density. And to further enhance our approach, we want to add additional legal or other binding regulations, for example, the greening provision, dimension limitations, the roof type. And one approach to achieve this could be by adding further information, for example, from X-Bau or X-Planung. And with that, I want to thank for your attention. That's it.